So hello friends, it is my fourth lecture. Before this lecture, I have described the application of hybridization. Means what is the application of hybridization? So there are several types of applications of hybridization. I have already discussed. Okay, so today we will discuss the steric effect. Okay, so what is the steric effect? Okay, so if you see here in this, they mention that on account of the presence of bulkier group at the reaction center, they cause mechanical interference, and with the result, the attacking reagent finds it difficult to reach the reaction site and thus slows down the reaction. The phenomena is called steric hindrance or steric effects. Means they want to ask that suppose that I have suppose that this molecule. Okay, cs2 suppose Cl. Okay, so in this molecule, if you see the main carbon center containing these groups. Okay, so suppose that in this, what happened here, suppose that any means on any reagent which is adding for, suppose that this is the starting material. Okay, so this molecule containing, there are several groups around the carbon center. Okay, so that's why reagent which either electrophile, okay, or nucleophile, if they want to attack on this carbon center, they will not easily overtake in this carbon. Okay, because there are bulkier groups, so mechanically it cannot reach on this carbon center. Okay, due to these bulkier groups around the carbon. Okay, so that's why this effect is called, means after that what happened here, the reaction will not proceed. Okay, reaction क्या होगी, reaction will be not proceeded. Okay, so this phenomenon is called what? It is called steric effect. Yeah, steric hindrance, you can also call this steric hindrance. Okay, so it is, so okay, so it is all about, suppose that this carbon, suppose that this carbon in this what, okay, I have to suppose that this one. So here you can also see these type of atoms. Okay, so this effect means this group causes the steric hindrance, means bulk, these are the bulkier groups, that's why any region will not attack easily on this carbon center. Okay, that's why it will be released out iodine, so reaction will be slow. Okay, first of all reaction will be, result क्या होगा, reaction will be slow. Okay, any reagent cannot reach easily, okay, towards where, carbon center. Okay, so is this matlab these groups causes here steric hindrance. Okay, so this is called steric effect. Okay, so I think you will be understand what is what I want to say. Okay, so if this is the some example. Okay, tertiary alkyl halides having bulky groups from tertiary carbocation. Suppose that this is the molecule. If chlorine will be released out, first of all these molecules create here steric strain, that's why any species will not release easily. Okay, so in this carbocation will form very high, means reaction will not forward towards intermediate formation. So that's why, due to what, steric hindrance. Okay, so due to steric hindrance reaction will goes very slowly, reaction will grow very slowly. Okay, and less product formation takes place. Okay, so it is the first application, it is the first one. Here it is also says the steric strain is released less strained species. Okay, in this molecule when reaction is, suppose that proceeded forward direction. Okay, so when chlorine will released out, carbocation will form, so here less strain will be means less strain will be created, you can say. Okay, because chlorine this is also a bulky group. Okay, so due to release of this chlorine atom, some strain will be released out and this will be formed. This is the intermediate. Okay, I have already discussed the intermediate. Okay, so second one is, it is the first. Okay, so if question will be asked, so like that question will be asked, which molecule suffer steric strains. Okay, suppose that this type of question can be asked. Okay, so first option is given. This is the, okay, and this molecule is also given. Okay, third one is, so you can easily identify which in which molecule steric strain will be more. Okay, so here if you see, this is the bulkier group CS3. Okay, in this it is less steric hindrance compared to, so suffer from steric hindrance इसमें सबसे ज़्यादा होगा, आफ्टर दैट इसमें होगा, because hydrogen is, size of hydrogen is less as compared to CS3. Okay, so that's why it is the order of steric hindrance. Okay, so it is the order of steric hindrance. Okay, so it is all about steric hindrance. So I think you can easily identify which molecule can suffer from steric hindrance. Okay, so the second point is also said that primary alkyl halide having quaternary beta carbon does not form transition state because of the steric hindrance around alpha carbon by the beta carbon. To release this state, it converts into carbocation. Okay, so in this molecule, it is saying that these types of, suppose that this molecule, okay, so in this what happened here, beta alpha beta, this is the alpha carbon, this is the beta carbon. Okay, so in this transition state not possible because release of chlorine is very hard. Okay, due to these bulky groups, this is the bulky group. Okay, you can, I have already this molecule. So this is the bulky group, that's why transition state will be not formed. Okay, and reaction will not go easily. Okay, so if you see here for carbocation, how it will form, if actually what happen here, carbocation will be formed first of all, so where suppose that acid will be added here. Okay, so these methyl group, where it will go, this will go from this. Okay, that's why this carbon form carbocation, but reaction goes very reaction will not go very easy. Okay, so it is the effect of steric hindrance. Okay, steric hindrance inhibits the resonance. This phenomenon is steric inhibition of resonance, means steric hindrance और क्या करता है, resonance को decrease करता है, decreases the resonance. Okay, so it is the third application of steric hindrance. Okay, so it is all about the steric hindrance. Okay, so if you see here, actually I have also this point I have also discussed again. Suppose that this molecule, okay, in this molecule, this is the bulky group. Okay, this is the leaving group. Leaving group means it in the reaction it will be easily released out. Okay, so this is the bulky group, this is the leaving group. Okay, so what happened here, it is said that primary alkyl halide having quaternary beta carbon does not form transition state. Okay, because of the steric strain around alpha carbon, okay, by the beta carbon, to release this it converts into carbocation. So इसमें क्या है, if you see here, this is the bulky group, so by which it means steric strain will be developed here. So for releasing this steric strain, it converted to carbocation. Okay, so which type of carbocation it will form like that. So here this one will be formed. Okay, like that. Okay, so it is the means this type of carbocation will be formed by which steric strain will be less. This is the you can carbocation. Okay, so it is all about steric strain. Okay, actually this paragraph is also saying something. I don't know what is want to say. It is observed that most of the attacking reagent always possess either a positive or negative charge. Okay, therefore for a reaction to take place on the covalent bond, the latter must possess oppositively charged center. This is made possible by displacement of the bonding electron. The electron is in turn may be due to certain effects. Some of which are permanent and other are temporary. The former effects are permanently operating the molecule and known as polarization effect, while the later brought to play by the attacking reagent and soon moved. So actually it is called that suppose that this is the reactant. Okay, reactant means this is the molecule. Okay, this is the reaction. In this, suppose that a reaction is proceeded, okay, in which reactant is converted to where product. Okay, so for this conversion there is a need of some reagent. Okay, and these reagent may be either electropositive or either either nucleophile or electrophile. Okay, so electrophile is it has electron deficient, so it will attack on the electron rich center. Okay, nucleophile having more means charge density of nucleophile is much more, so that's why it will where it will attack on the electron deficient center. Suppose that this molecule is given. Okay, so this carbon center having electron deficient. Okay, so that's why nucleophile will attack on this. Understand? So it is, I want to say this one. Okay, so by which reaction will be proceed and product formation takes place. But what happened here? Suppose that this reaction, this is the reactant molecule converted to products. Okay, so directly reactant प्रोडक्ट में कन्वर्ट नहीं होगा, बीच में क्या होगा, एक इंटरमीडिएट स्टेज आएगी, इंटरमीडिएट form. What form? Intermediate species form. Okay, after that product will be converted to this. Means first of all electrophile and nucleophile is needed for converting reactant to products. Second one, intermediate will be formed. Okay, so there are a lots of intermediate will be formed like carbene, carbocation. Okay, or carbocation, carbanion. Okay, carbanion and nitrine. Okay, free radical like that. So it is formed, it is called intermediate and it is formed in between the reaction. Okay, by which conversion into product is very means less time will be taken for that. Okay, so very easy way it is, after intermediate formation it will convert it to products. So it is the I want to say. But for this one, suppose that this is the molecule. Okay, here what happen here, some electrophile, suppose that this the reagent either electrophile or nucleophile, it will attack here. Okay, so some groups which proceeded the reaction, means nucleophile will attack very easy. When some groups, suppose that electron, these are two groups, actually two groups, electron withdrawing groups. Okay, and electron releasing groups. So suppose that these are the electron, this is the electron releasing groups. Okay, so reaction will be forward very easy because the electron density proceeded this direction. Okay, so that's why this bond will be easily migrate to oxygen. Means this electron, this double bond, one bond will be broken, electron density will proceeded on oxygen atom. Okay, so these groups means supported to this conversion. Okay, so that's why it is so this is the electronic effect, you can say, effect. Okay, so I want to say this is the electronic effects, and so it is called electronic effect or electronic displacement type. Okay, so if I think you should be understand, but here I again want to discuss this point. Suppose that this is the reactant. First of all, it will converted which intermediate. Okay, I have discussed in the back side. Okay, intermediate. Okay, I have also discussed the which type of intermediate will form. Okay, then product will form. Okay, so it is the reactant. So suppose that this is my reactant, and it uses some reagents. Reagents may be either electrophile or nucleophile. Okay, by which product will be formed. Suppose that this will be CO, like that. Okay, suppose that it will form. So here I want to actually it is not my part to want to discuss. I only want to discuss this point. So here nucleophile will attack. Okay, तो सम ग्रुप्स इसमें क्या है, दिस मालिक्यूल में कुछ ऐसे ग्रुप्स होंगे जो इस रिएक्शन को प्रोसीड की जल्दी न्यूक्लियोफाइल वेरी इजीली अटैक ऑन दिस कार्बोनिल. सो इफ इलेक्ट्रॉन releasing group attached, then then reaction will be forward. Reactant you can say product में easily convert हो जाएगा, means reaction rate will be high. So electron, this is the electron releasing group. Suppose that I have mentioned here. So first of all you should be know about the what is the electron releasing group. So these are the electron releasing groups. ओके, इट विल क्या है, इट विल इलेक्ट्रॉन को रिलीज करेंगे वेरी इजली. ओके, सो इट इज़ द इलेक्ट्रॉन रिलीजिंग ग्रुप. ओके, सम आर द इलेक्ट्रॉन विड्राइंग ग्रुप्स. इलेक्ट्रॉन विड्राइंग ग्रुप हुआ विच क्लोरो all halogens. Okay, bromo, iodine, chlorine. Okay, so it is the NO2. Okay, so it is the electron withdrawing group. Okay, so if electron withdrawing, suppose that this starting material containing this one. Okay, so the electron density will proceed towards chlorine. Okay, so that's why reaction will goes less as compared to this one. Okay, because here electron withdrawing group is present. So suppose that this question will be asked, which reaction go very easy. Suppose that if they mention here CS3, CS2, COCS3, if very easy, if you add nucleophile. What nucleophile? Okay, suppose that this one दिया है, then this one दिया है. Okay, so what is the correct answer? This molecule will convert into product very easy. Okay, so friends, actually my battery has been discharged. Okay, so that's why we will left here. So thank you friends, I will meet you later. Okay, after this taking new problems. Okay, so thank you.